Hey guys, this is Team Wavy here with our first group presentation. It's made up of Pedro, who's the front-end developer, Jesse and Emma, who are the back-end developers, and me, Seth or Micaiah, the data organizer. Um, Go to the next slide. The premise of this project is making a graphical interactive map as a way for um, users, instructors, researchers to view local and regional climate trends. The goal of this is to imitate windy.com in terms of the interface and the flow of the website, where you have different layers of like temperature, wind speed, dew point, and a time graph on the bottom. And we would do it by month. Um, for instance, you could pick out July 8th. What is the expected temperature in Gainesville, Florida on July 8th? And this would be averaged over many years of climate data.
Hi. So the software architecture will consist of a front end, a back end API, and a database. And we'll be doing this to create an interactive dynamic user interface. So the front end will use HTML and CSS, JavaScript, using React.js, the fetch API and DOM manipulation. And that'll enable user interaction and communication with the backend. So the backend API will use the GIN framework and SQL operations to request information from the front end.
Okay, so for the front end, we're gonna use React. We're gonna use Leaflet.js, which is a interactive map library, and I'm using Figma also to design the interfaces that we're gonna use. So here's kind of what a wireframe of what we're gonna do. So we're gonna have the main focus of this application is the map. So our initial photo should focus on the Florida map, where we're gonna have the weather, we're gonna have the different colors. We're also gonna have on the right side, you can see the blue box, the matrix switcher, where you can switch between temperature, precipitation, minimum temperature, maximum temperature. Also, one of our ideas is we have time and then we're able to apply that is create a OpenAI chat box, so we can also help the user ask questions and answer about our data and make predictions about weather. So individual responsibilities. So my goal is front-end developer. That's what I'm focusing on. So I'm designing also the user interface on Figma.
My goal is gathering relevant and accurate climate data over at least 20, hopefully up to 40 years of data, and making sure that's consistent with the map grid.
My responsibility was creating a server application to connect the database to the backend using Golang.
And yeah, my job was to create the API endpoints and queries.
Our project progress consists of setting up a GitHub repository and a Jira project planning board. We've also identified an interactive map library, and we have tested it with dummy data. We have initialized development of API endpoints and weather data identification and gathering. This is our current map using dummy data, which has a hover option to check the location of the counties, as well as buttons to click for average temperature, minimum temperature, maximum temperature, and average precipitation using the heat map.
Okay, some of the issues that we're having is that it's really hard to find appropriate data sets for this project. And there's a lot of data sets regarding weather in the internet, but they are very disorganized and they don't focus exactly on so there's a lot of data regarding stations and maybe counties, but maybe we want to focus on like very small areas, and it was really hard to find that. Also, the map library that we're using Leaflet. It relies heavily on exact coordinates location for us to like apply the colors, apply the animations. And so that makes it really hard because we need to identify data sets that give us exactly the coordinates that we want. Also, Leaflet sometimes is not as a reliable library that we want. Sometimes it was down on a date, so the map wasn't displaying. Also, sometimes it's limited regarding features, so we also have problems applying animations such as heat maps and interpolation, so we kind of have to define the Florida maps as grids. So that was a difficulty that we have. And we also have a lot of difficulty like with the amount of data, because we have a lot of data sets coming in from different dates, so we need to make sure our queries are as efficient as possible. Otherwise, it may lead to performance issues. Okay, some of the next steps. So next steps for me should definitely try to kind of finish the front end and start integrating, stop using dummy data and start integrating backend data into the front end interactive map. Also, as I said, kind of continue to develop the front end and adding the additional components. And also testing and enhancing the front end performance.
Emma and I are going to tackle the changing the API structure to be organized by longitude and latitude instead of the county and station name.
Thanks to our advisor, Stephen Mullins. He directed us to a really useful data set. And my next step this week will be automating the collection of that data and mapping it to the coordinates Pedro has given me to display on the map.
So this is a presentation. Thank you very much.